AI it's everywhere now, right? It's changing how we do everything, from writing code to uh, how businesses interact with customers. And it sounds amazing.
It does.
But today, we really need to get into the darker side of this. The unavoidable truth that AI is also making cyber threats exponentially more complex.
It's bigger.
So much bigger. And this isn't some, far-off sci-fi concept anymore. It's here. It's happening now. It is absolutely weaponized.
Right.
And that's the critical thing to understand. Before we jump into the specific attacks, we need to talk about the new engine driving all of this. It's this powerful combination of two things: the autonomous AI agent and the large language model, the LLM.
Okay, so break that down. The agent is what?
Pilot?
The agent is the pilot, yeah.
Yeah.
It's the executor. It plans the attack. It navigates the systems. It makes all the high-level calls.
The agent is the muscle, the one actually running the mission.
Precisely. And the LLM is the brain. It's the specialized tool the agent uses for all the heavy lifting, communication, complex analysis, generating text.
Sure.
So our mission for this deep dive is to show you how that pairing is just radically changing the economics, the whole criminal return on investment. We're going to walk you through 6 really critical examples that are popping up right now.
And the goal for you listening to this is not just to get the mechanics of these new attacks, but to really truly grasp how the fundamental costs and the effectiveness of cybercrime are changing. It's like the bad guys just got a massive, practically free, super skilled labor force.
And then we need to understand how they're using it. So where should we start?
Let's start with something that seems kind of old school, but AI has totally flipped it on its head. Automated entry points. We're talking about, testing a system's security, but having an AI agent run the whole show, like this research system called brute force AI.
Right. And what makes it so different is the efficiency in its understanding of the target. The agent runs on its own, but it uses the LLM for perception, for the heavy lifting. Yeah. The LLM will say, parse a web page, a login portal, and it analyzes the whole thing. It identifies exactly where the login forms are, where the user ID field is, the password box.
And it is terrifyingly good at this. The sources show this version was able to correctly identify the login areas with, something like 95% accuracy?
95%.
Yeah.
And once the agent knows where to type, it directs the attack.
Yeah.
And it's not just doing the old brute force thing of, trying every single password combination.
Because most systems have basic protections against that, right? The 3 strikes you're out rule, you fail a few times, you get locked out. So how does an AI get around that?
It's smarter. It uses strategies to avoid getting caught. It switches to something called password spraying.
Password spraying.
So instead of trying 1,000 passwords on one user ID, it takes one really common password and tries it across hundreds, maybe thousands of different user IDs.
I see. So it only tries one password per account.
Exactly. So it never hits that lockout policy. And the AI agent runs this whole complex process by itself. No human oversight. The speed and success rate just go through the roof.
And that speed, that autonomy, it leads us right into our second big threat, the death of the human flaw in phishing emails. We always used to say the dead giveaway was bad grammar, right? A spelling mistake.
And now we have to untrain everyone on that advice. It's basically useless.
Because the AI is just perfect.
An attacker, it doesn't matter what their native language is, they can just feed a few simple prompts into an LLM, and out comes this perfect, natural-sounding text in English or Spanish or French.
So that raises a big question for anyone listening. If the grammar is perfect, what are we supposed to look for now?
You have to look for hyper-personalization. The AI is designed to scrape social media, company bios, public info, anything it can find to build an email just for you.
So it might mention a conference you just attended or
use jargon specific to your team. It makes the email feel so much more legitimate than those old generic messages, so much more trustworthy.
And the economics here are, they're the real story. IBM did this experiment. They compared a human-crafted phishing attack, which took 16 hours of skilled work, against an AI-generated one.
And the AI attack, it took 5 prompts, 5 minutes. And it was almost as effective at tricking the target.
16 hours versus 5 minutes.
The efficiency gain is just astronomical. An attacker can launch hundreds of these high-quality personalized attacks in the time it used to take a human to craft just one. That barrier to entry has completely collapsed.
So we need to shift gears a little bit because we've talked about getting in, but what about making money? How is this intelligence orchestrating the entire monetization pipeline?
Right. We're moving from simple entry attacks to high-value really sophisticated fraud.
So if AI makes those smaller attacks cheap, how does it scale up to the big price tags? Let's talk about AI-based ransomware, specifically this research project called Prompt Lock. This is where the AI agent really becomes the director of the whole show.
Absolutely. So once the breach happens, the LLM plays this critical analysis role. The agent feeds it the victim's data documents, spreadsheets, proprietary code, and the LLM analyzes it all to figure out what's most valuable.
So it's not just encrypting everything, it's finding the crown jewels.
It's finding the stuff they know the victim will pay a lot for. It's not going to waste time or encryption effort on junk files.
That's intelligent extortion. And once it finds that data, the agent uses the LLM to write these really personalized ransom notes, right?
Exactly. It will list the specific files it's holding hostage. That makes the threat feel so much more immediate, so much more real. It just forces the victim's hand.
And this leads to something the source calls polymorphic attacks. What does that mean in this context?
It means that because the AI agent is generating the attack code in real time, every single instance of the attack can look different from the last one.
And that's a huge problem for defense, isn't it? Because traditional security relies on recognizing a threat's signature.
It's a fundamental problem. If the code is constantly changing its own DNA, you're trying to catch a chameleon. Your signature-based detection is, well, it's useless.
So you could have this entire thing, this ransomware as a service, or RAS, running totally in the cloud, powered by this constantly adapting AI.
That's the perfect description, and it's happening.
Okay, so moving from holding data hostage to just outright theft, deepfakes. This is where the core trust we have in business, believing what we see and hear, just completely evaporates.
And it requires so little to work. The generative AI models, they only need maybe 3 seconds of your audio to create a totally believable synthetic voice clone.
3 seconds.
3 seconds. For video, it takes a bit more, but the tech is advancing so quickly.
And I have to stop you here because this isn't some future threat. The sources are really clear on this. These are things that have already happened. We have hard examples of this costing companies millions.
That's right. Back in 2021, there was an audio deepfake that convinced an employee to wire $35 million. The voice sounded exactly like their boss.
35 million.
And then just this year, in 2024, they upped their game. A video deepfake was used during a video call. It looked and sounded just like the company's CFO.
And how much did they lose?
$25 million.
So if that's the case, if audio and video are essentially dead for verification, what's some immediate, actionable advice here? The old rule was, believe what you see and hear. What's the new rule?
The new rule is profound skepticism, mandatory friction. Security teams have to mandate multi-factor communication for any high-value transaction.
So if the CEO calls asking for a wire transfer,
the procedure has to include a mandatory callback on a known trusted number or a verification message through a completely separate channel, like a corporate app. The bottom line is this. If you are not physically in the room with that person, you can no longer trust the communication alone.
Okay, let's pivot now to how AI is automating the creation of attack code itself, weaponizing public information, AI-powered exploits.
Right. This is about democratizing hacking. So every security pro knows about CVE's common vulnerabilities and exposures.
They're basically public reports describing flaws in software.
Exactly. But before, turning that dense technical report into actual working exploit code, that took a really high level of specialized skill.
But now we have the CVE genie, a research agent that, just reads the report.
It takes the published CVE report, feeds it to an LLM to pull out all the key details and the logic, and then the agent itself writes the exploit code needed to take advantage of that vulnerability.
And the economics of this are just astonishing. It had a 51% success rate, right?
A 51% success rate at generating working functional code, just by reading the documentation.
I mean, are we sure that number's right? 51%, that just sounds unbelievably effective for a machine just reading human-written text.
It is, because the LLM is brilliant at synthesizing that kind of complex technical logic. It connects the dots. But the real game changer for the criminal economy is the cost.
Right.
The cost to generate each working exploit was less than $3.
$3. The profit margin is practically infinite.
And the impact is huge. People who know nothing about coding, who have zero technical skill, can now exploit these complex vulnerabilities. The barrier to entry is gone.
Which leads us to the final, most advanced level, the AI agent that runs the entire operation, the full kill chain.
And we've seen proof of concepts for this already, where an AI system was weaponized to carry out strategic attacks from start to finish.
And this agent is making strategic decisions, not just executing a simple script.
Oh, absolutely. It makes tactical decisions like how to get into a network, but also strategic ones. It finds high-value victims on its own. It analyzes the data. It steals. It orchestrates the entire extortion.
It sounds like it's also incredibly smart about the money part.
It is. It creates false personas to hide behind. And, critically, it calibrates the ransom demand. It knows asking for too much means you get nothing, but asking for too little is leaving money on the table. The AI makes those perfect economic calculations automatically.
So all of this really comes down to what one of the sources called the vibe coder. I love that term.
It's a perfect summary, isn't it? Historically, to pull off one of these complex multi-stage attacks, you had to be an elite hacker. You needed deep knowledge of code of networks.
But now
the attacker just needs the vibe, the high-level idea. They tell the agent what they want, and the machine does all the complicated, difficult work. The pool of potential attackers just got infinitely larger.
So let's tie this all together. What does this mean for the security teams, the professionals listening to this deep dive? The big theme here is that AI has just collapsed the skill barrier and created this astronomical cost advantage for criminals.
Right. 5 minutes of work gets you the same result as 16 hours from a human professional.
So what's the synthesis? What do people need to walk away with?
That AI attacks are not going to plateau. They're not just going to get a little worse. They're only going to get better and faster and cheaper every single month. So defense is no longer optional.
And it can't be reactive anymore, can it? You can't fight an AI-driven polymorphic attack with static, signature-based tools from 10 years ago.
Absolutely not. Defenders have to leverage AI themselves. For prevention, for detection, for response, you have to operate at machine speed.
So we need defensive AI that can analyze these attacks in real time, that can spot behavioral patterns, not just signatures.
And it has to be predictive. It needs to be analyzing that CVE documentation, just like the CVE genie, but using that knowledge to patch things before the criminals can build an exploit.
So the future of cybersecurity it's a new arms race. Good AI versus bad AI.
It is. It's not human versus human anymore.
Yeah.
And you, the executive, the professional listening to this, you need to make sure the good one wins. The resources, the intelligence, the strategy, it all has to be deployed to fight back at machine speed.
And the most provocative thought to leave everyone with, especially thinking about those deepfake examples, if you can't trust audio and you can't trust video, the most human parts of communication, then the future of security might rely on protocols that are specifically designed to be, well, a little bit annoying.
Friction is the new security. Expect mandatory callbacks. Expect multi-channel verification. That's what trust is going to look like.